Give me the question mark.
Your first derivative should be 20x on numerator.
Okay.
And go ahead and move on second derivative.
Wait, what do you mean?
20x on numerator. And those denominators, similar thing but square.
Sorry, I blinked.
So, guys, at this stage, you should be able to take both derivative accurately 100%. Otherwise, you don't really belong to this class.
That's hard.
Speak if somebody came and take derivative x cubed.
Look, you should have just let me take back my time.
You already turned in, did you?
Oh,
Did you already turn in that test at the
Very
moment?
cool.
Yes, you did. So, if you came and do that, that means you don't even belong to my class. According to your work ethic, you don't belong to my class.
I come.
And that's what happens when you don't practice, so you screw up those stupid things. How many of you guys finished your second derivative? Already done? Is it right?
Your secondary?
I take out negative because that makes easier for me to do normal line tests.
derivative of 2x. 2x.
Oh, I got it, okay.
Anyway,
So you guys
Just
need.
factor in 20. Or 12. You could.
You don't, for the first one, you don't have to distribute it, like, the x squared minus 4 squared, so just keep it there.
Your life is a lot harder if you just do that. So those are the questions that you guys should be like, could have done in 5 minutes, 100% correct across the room by this day and age, because we are going to do derivatives so many times. It's not even funny, like how many times we've gone through. But you guys still have some issue with it, and that's a big problem. Okay, but anyway, in UCF, what happened in UCF is they actually, this is one of the UCF questions. It's from the textbook as well as a UCF textbook. US final exam question as well as midterm exam question. So as on both exams, So it's a very big deal. The exam, this question worth around 20 to 25 points. So you have to be able to curve sketch the whole thing without anything. Now, what's the nice thing about UCF is they actually give you the first derivative and they actually give you the second derivative. So in case that you screw up your derivative, which is most of you guys did. Okay, but that wasn't the hard part. The hard part is all the knowledge behind all those things that is gonna go in along with it. So that's my first derivative. You should know how to take a derivative very easily. So here now this one is gonna be 20x over x squared minus 4 squared, and this one is gonna be minus 20 over 3x squared plus 4 all over x squared minus 4 to the third, I think. Okay. Okay, so first of all, in general, algebra 2 and in general that you should be able to find x-intercept and y-intercept, right? Suha, how to find x-intercept? Y equals 0. So this is something that you should automatically know. So y equals 0 in this case is which is going to be it. So we're going to set y equal to 0, right? And solve for x. So at this case, 0 is equal to f of x. So it'll be 2 times x squared minus 9 over x squared minus 4. And if you were in my class last year, we go through this like very, very detailed how to graph this kind of function. So you don't worry about the denominator because you only worry about top equal to 0. So it'll be x squared minus 9 equal to 0, x equal to plus minus 3. We should know how to do that, right? Y-intercept, this is the sec x equal to 0. That's even easier. So it'd be 2 times negative 9 over negative 4. Because the x is equal to 0, so that's going to be negative 18 over negative 4, which is 9 over 2. So you're going to get 0 and 9 over 2 here. And this one is going to be 3, 0, and the negative 3, 0. So those are the crucial points that you can graph. I'm not going to determine domain and range. That was usually last step, so I'm going to put that off. I'm going to say domain and range is all the way on the bottom. But however, you should be able to figure out domain is, so let's figure out domain here. And let's figure out range on the bottom. So domain, basically domain, only time that domain does not exist is what? When does it define? When does that define? 2, that's it? 2 positive negative 2. So domain is a vertical asymptote. So denominator equal to 0. So therefore it's going to be x squared minus 4 equal to 0, x equal to plus minus 2. So that is going to be negative infinity to negative 2, union from negative 2 to 2, union from 2 to infinity. So that becomes very easy. So you say, oh, denominator equals 0, vertical asymptote, and stuff like that. So then you can kind of get this 2 things in one stone. Other time domain has issues when you have radicals. Okay, either you have radical, you have logarithms, or you have a rational function. In this case, rational function, vertical asymptote is a big deal. How about horizontal asymptote? How do I find horizontal asymptote?
The power, right?
Yeah, it's the lowest denominator, it's the power. I don't know how to explain it, like on the f of x and the x squared, you put everything over x squared.
Okay, so what do you do with that? That you had to know that definition.
See if the power is the same on top of
You gotta start with something else.
even if we're-
What's the horizontal asymptote definitions?
Oh,
Limit x approach to negative infinity of f of x we talked about this before, so therefore it's gonna be limit x approaching infinity. And you're right about that thing, so it'll be 2x squared, so minus 18, I'll distribute it, and over x squared minus 4. And you get divided by highest degree, so x squared, x squared, x squared, x squared. You remember this? Limit x approaching infinity of 2 minus 18 over x squared over 1 minus 4 over x squared. So when this reach infinity, this part has become insignificant, so that's equal to 2. Y is equal to 2. Okay. Critical point. What is critical point in this case? X equal to what? X is equal to 0. But what else? X equal to plus -2. Now, this one that somebody like asked me last period says, whether +2, -2 is a critical point. Because essentially, I rather told you it is, but it actually isn't. Because I rather told you it is because that way you can do a number line test based on those points. Because you cannot avoid a number line test without not treating those 2 points. So you had to be careful with this. So if I really want to be picky, that there is no critical number for this one because they cannot do plus -2. But in order to test increasing, decreasing, I really need to go through a number line test. And a lot of you guys didn't do a number line test yesterday, which is kind of sad, because I cannot give you anything if you did not do a number line test. But what are we testing? Just look at here. 20x. That's the first part I'm going to do a testing, right? Now, do I need to test x squared minus 4 squared? Why? Because always positive. Doesn't matter what number I plug in, that essentially our number is going to be positive. I can do it if I wanted to, but I can write it down, but that doesn't change anything. So because I can plug in any number in here, technically that eventually is going to square anyway. So that's going to be positive, 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 positive. The only thing that's going to change the sign is 20x. So therefore it's going to be negative, negative, positive, positive. So the sum up is going to be positive, positive, negative, negative. So it's going to be decreasing, decreasing, increasing, and increasing. And then therefore your increasing, decreasing is going to be negative infinity to -2. Union -2 to 0 is going to be decreasing. And the increasing is going to be what? 0 to 2, and then 2 to infinity. We already know that, but do we have relative minimum, maximum here?
Yeah.
Where?
Just,
Whenever positive goes to negative.
Positive go to negative, do you see that?
no. It's not
How about the other way, how about minimum?
0.
Okay, x equal to 0, and then that's going to be relative minimum, right? And we already know 0 is at -2, so we know that point. That's important because I know y value. A lot of the time that, whatever you did a test yesterday, you did not go find the y value. You find the x. How are you going to graph with the x? It's like your coordinate's 2. What the hell is coordinate 2? To what? To comma some type of number, I don't know. So what do you plug into? Into the original equation, right? So that's sort of things you have to worry about. Okay, now the number one test for concavity. So concavity inflection point. So this one is f double prime x graph. And which value I'm testing? -2 and 2. Now, some people's gonna ask me, do I need to test this part? Why not? It's imaginary, and you don't need to worry about it, right? You don't need to test the top, okay? And you don't need to test the top also because you don't need it including that's the part that you need to test. That's gonna be positive anyway, because it doesn't matter what number you plug in. If it's +4, it doesn't matter it never be negative. So I don't even test this part in terms of putting right next to here, but I do put negative 20 though, because I don't like that negative 20.
Always negative.
Yep, everything's gonna change to everything negative. What else? X squared
Minus 4.
minus 4 to the third. Now why to the third I opt in to do it instead of second power?
It's not always
It's a
negative.
So negative 2 to the third power is negative, negative 2 to the second power is always positive. Coco, you got this? It looks like it's only now.
Okay.
Okay. So then it's gonna be, if you have negative 4 here, that's gonna be positive, so it's gonna be positive. This part's gonna be negative, this one is positive, so it's gonna be negative, positive, negative. So it's gonna be concave down, concave up, and concave down. Now here's the comes the crucial question. Inflection point occur where?
When does it change?
When there's a change.
Negative 2 and 2.
So you think it's negative 2 and 2?
No,
Dang, I'm wrong.
Yes, you're wrong, because you forgot to do again.
plug into the
Plug into the original, right?
Yeah. Your domain already restrict that, so that's no longer inflection point. Inflection point is none. Because that's not it. So critical number, this part to be strictly, it's actually out as well. Because it's not exactly with it, but you should still base on this point. If I would just ask you what is critical number, you just say it's 0.
Oh, because it's an asymptote, that's why.
Yes.
That makes a lot to go.
20 minutes later, Sid finally got it.
At least he got it.
Yeah. If you were to do homework from a long time ago, you would have got it. Huh.
Do it for the number line test, but don't. write.
Okay, so what we're gonna do is we're gonna grab this. So now it's curve sketching.
What was the
Yes.
range? Wait,
You had to graph all this information.
are we the range?
Huh?
The range.
I don't want to do range. There's a reason why I don't want to do range. I can't really tell what the range is until I can graph it. That's probably easier to tell. Okay, so that's why I do range last step. So what I'm gonna do is I'm gonna always indicate if this is vertical asymptote. Not all the questions have vertical asymptote, but vertical asymptote is the biggest badass of the badass. Nobody touched them. They are the badass. Okay, nobody touched them. Okay, so we're gonna say -1, -2 here. That's gonna be a
It's a badass asymptote.
You never seen those shirts? So.
You
Um,
say shirts?
Yeah.
Yeah, he's a sure.
No, it says something like that. I don't know. Remember? You can look it up. Asymptote image. Mother F asymptote, something like that. I don't know. So. Horizontal asymptote. Where's horizontal asymptote? 2.
Other f of x and bad asymptote.
And there is a reason why I graph asymptotes first, because asymptote is the most important thing, because it structures the whole rational graph. Very, very.
That's funny.
Was it?
Holy shit, look at that asymptote on the mother function.
So,
What math people say when they see a milk.
now we're gonna get this. We got this information already. We can check it out. We can say, hey, we did a vertical asymptote, horizontal asymptote. We did that. How about x-intercept, y-intercept? Well, not just a point, so it's just -3 and a +3. And it's gonna be, this one is gonna be 3, 0, this one's gonna be -3, 0. And then you say, okay, well, let's go on to other things. Let's go on to taking the y-intercept. Y-intercept is gonna be 9/2, 9/2 to the 3, 4.5. So roughly right here. Send? Left one way. Okay, so now I got those 3 points in there, I got those 2 asymptotes in there. Now I just have to graph according to their increasing, decreasing. Okay, so what information we already did? We did this one, and we did this one. Domain we don't need to cover. Critical point is at 0, 0. What else? Relative what? Maximum, minimum, and this. So minimum I draw a happy face. I draw a happy face on that point. Okay? Now I'm going to go into detail to an increasing, decreasing part. So what's the function from negative infinity to negative 2 is what? Decreasing, right? So this one all the way to negative 2, but it must go through this point. So it's decreasing. So I'm going to draw something down. I don't draw the solid line. There's a reason why I don't draw a solid line, because I don't know the concavity is. So I draw some type of dotted line that's going through there. And I'm going to say that's decreasing again from negative 2 to 0. So it's decreasing. So it's going to be here. And after that, it's going to be increasing. And here is going to be, after that, it's going to be increasing. But it's going to go through 3, 0. Okay, so, but I draw a dotted line. But now I have to go with concavity. Concavity is this. You have to very obviously concave down. Sometimes it could be like this, right? So, but this one's concave down, so it's this way. And this is gonna be like this. But you're not gonna touch the asymptote. And this is increasing, concave up. And this is concave down. So that's pretty much my generalized graph. And that's my graph I'm supposed to come up with. Increasing, decreasing, all that, okay? So you guys gonna try one? This one might be, has another asymptote. I don't know if you guys know how to find another asymptote. There's one more type of asymptote, do you guys recall? Slant, good job.
Oh, yeah.
How do you find slant?
Long division.
Long division, yes. When numerator is greater than denominator, it's automatically a slant asymptote. So think about how you find slant asymptote, but you can probably graph without slant asymptote today. But you gotta go through this each individual thing, see if that's true. So here's a function, so x squared minus 2x plus 4 all over x minus 2. Yeah, that's f of x. And that's practicing take a derivative properly. I'm gonna do it on this board. I'll race you.
Oh, okay, cool.
I'll give you 2-minute head start.
Thank you. We need it.
Andres can definitely beat me. Andres is fast. I don't know, it's accurate, but it's fast. I'm gonna just write down a problem, so that way I'm not
Just
cheating.
do it in his head and he's gonna know exactly what's gonna happen.
What?
He's
You're
a
gonna do it in your
calculator.
head, so when the 2 minutes are up, you just know it's right.
Oh no, I'm not as smart. Especially after stroke.
Yeah, we gotta check our headsets. I don't trust it.
Yeah, what do you feel?
Are you still waiting? Jesus Christ.
Give you a head start.
I know. Sorry. Okay, go.
Not only do it fast, do it accurately. Okay, I'm gonna start. Fine. Oh, wait, now it's 60 seconds.
You want us to do all those things and then.
Yeah,
Wait, what-
finding all the
What are we
things.
finding?
Finding all those things.
First order, not second, first order. That's not on the two.
I don't know.
Can I start saying?
No.
60 seconds, right?
Second class.
You have like, you can do it in 30 seconds off clock.
I don't even do 30 seconds. Yeah, I'm not sure.
I found first order.
Phone second, right?
You could, just write the word confidence. From your soul, you know.
Sam, you did the second grade.
Quick question, what'd you get for F prime again? What'd you get for first?
Did you finish the second one? Did you finish the second one?
Wait, I
You can see it? Yeah, for sure. We can see it now. I didn't see it now. Yeah. I don't know. Come on, hurry up. It looks so.
Damn, bro,
I
it's
think
long.
Your experiments for us over experiments for school. 4x. I'm reviewing it.
That is something. I think I did something wrong.
This? I'm sorry, I was looking because I finished figuring out, but I think I did something. Okay, deal.
I didn't get that.
Plus 8.
John, you did second grade. Yeah, you did second grade.
So 8 over x minus 2
To the cube?
to the cube.
Hell yeah.
Okay, now find all the information.
Right. Did I forget another?
Those of you guys don't know how to find oblique asymptote or stand asymptote is a long division.
Oh, you mean for the top? Oh no, I'm not doing that.
How much time I have?
How much time do you have? That makes sense. It's one, oh, you have 2 minutes.
Oh,
2
we
minutes?
have to find all the stuff on there.
Yeah. X-intercept. How do I find the x-intercept? Y equal to 0. Ugh, quadratic formula.
Can we not do it?
Wait, we can do quadratic formula?
Yeah.
It's been a while.
So much is a box.
X equal to negative b.
Plus
Yeah.
the square root.
So it's 2 plus minus square root what?
Square root of 4
4 minus what?
4 minus 16.
4 minus,
1, oh wait, what's the?
Over 2, over 2. Yeah, 4 minus 6.
4 minus,
I don't know. It's
4 minus.
4 AC. That helps.
Oh, there is no, yeah, there is no. So this one is what, 14? I think 12, right?
4 minus 16.
16?
Yeah.
So 16 over 2a. So, whew, there is no x-intercept. Because the inside radical is negative,
Do you only need the numerator for x-intercept?
pretty much, only in the numerator. Good.
Oh, that's cool.
Y-intercept, so like we kinda got luck out there. There was no x-intercept there because it was a complex number. So there's no discriminant is negative, so there's no x-intercept.
Look, it's over there.
Yes. Okay,
Wow.
so y-intercept is what?
4 negative
4 over negative 2, so it'll be 0, negative 2, I would say.
Yeah.
Okay, vertical asymptote,
2.
2. Horizontal asymptote, none.
Right.
Critical point, x equal to 0, and x equal to 4. Okay? Okay, so increasing, decreasing, so if I were to do number line test, I don't need to do the bottom, I just do x times x minus 4, I think. It's gonna be 0 and 4. This one's a negative, this one's a positive, positive, right?
Negative 2.
Oh,
And this one is negative, negative, positive, so positive, negative, positive. So it's gonna be increasing, decreasing, increasing. And so are we okay here? What else? Maximum at where? Max at 0, what? 0, negative 2.
Right.
Okay.
Minimum
Minimum at where? What?
Hold on. 16.
Minimum at 4, what?
6.
6? Okay, concavity, so concavity is just 2, right? And x minus 2 to the 3. So that's gonna be negative, positive, so it's gonna be down, up, and there's no critical point, right? Because 2 is not critical point, so I'm gonna draw it. So at where 2 is the, okay, and at 0 and negative 2, 0, negative 2, so it'll be right here. And at 4, 6, so 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, so something like this. So it's gonna be increasing, decreasing, and then, wait. It's gonna increasing to 0, decreasing from 0 to something else. Am I missing 2? Oh, I'm missing, I did it wrong here. This one you need to do 2 here also. So I'm gonna redo this one, sorry. 0, 2, and 4. Why is that?
Undefined.
Yeah, undefined, so, sorry, this one's gonna be positive, 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 and this one's what? Negative 4 to here, that's gonna be negative, negative, and negative, positive, so it's negative, positive. So it's gonna be increasing, decreasing, and it's gonna be decreasing, increasing. Now, there is a oblique asymptote. How do I find oblique? Long division. X squared minus 2x plus 4.
It's just calc with a little bit of control.
x minus
I take
2.
a little bit of like
So
a-
be x squared, x, equal to x squared minus 2x, 0,
actually has
4.
next time.
So x is gonna be your asymptote, oblique asymptote. So your graph end up to be something like this. And the graph's gonna be like something like this. And it's concave down and concave up, so it's perfect.
You were recording?
Yeah.
See you tomorrow.
Right.
Dude, it's the Aloha.
It smells like